Hi guys. So I just want to jump straight into this electronics course and begin with a tutorial on blinking LEDs, rather a single LED using delay commands. Now I'm going to be doing this tutorial with a microcontroller called a Teensy. And the main reason why I'm using a Teensy is because it was introduced to me at work. That's the type of microcontroller that we use at work, so I'm used to it. However, you can do the same thing for an Arduino Uno, um, an Elegoo Uno R3, and all these other various brands of microcontrollers. They will pretty much do the same thing, just with different clock speeds and different memory usages. Um, every microcontroller, including Teensies, come with a controller schematic which tells you about the pins, and whether they are analog inputs, whether they are pulse width modulation, whether the pin is ground or whether the pin is voltage in, etc., etc. So, um, the blinking with LED, it's quite simple, and I'm going to first of all draw a circuit schematic using this example breadboard because we're going to do this on a breadboard. Now, I've got my microcontroller already slotted into the breadboard, and I'm going to just draw that there. Okay, and I'm gonna try to color it in as best as I can. I'm gonna try and color it in as best as I can, just so that there's some consistency going on. Now, on every microcontroller, like I've just said, exists a certain amount of pins. Okay, exists a certain amount of pins. Now, on a Tinsy, the pins here and there are very important because the pin on the top right corner is the voltage in pin, and the pin on the top left corner is the ground pin. And I'm going to denote the ground as GND, and I'm going to denote the VIN as V subscript IN. Now we are going to set the voltage and ground onto the same side of the breadboard. Okay, we're going to set it onto the same side as the breadboard. That means we're going to have a wire from V in going to there, such that this whole strip is live with voltage. Now, typically in a Tinsy, the Tinsy has a V in range of, if I just read it on my schematic, of 3.6 to 6 volts. Okay, so because I've connected the V in pin to this strip on the circuit board, this whole strip is now live at least 3.6 volts. Now my ground, I'm going to connect it to this strip here, the blue strip, and I'm going to denote that yellow. So I have a wire going from there to there, such that this whole strip is VN, this whole strip is ground. So I'll just do that there, and then I have VN as so. Now, I'm gonna use a simple green LED. Let me just literally just put a green LED there. And on LEDs, you typically have two pins. One is the pin for where it will take voltage, so that's called the plus pin, and the other pin, the shortest pin, it's where it will go to ground. Because on every circuit ever, you need to go back to ground or go back to the negative end, sorry, positive end of the terminal. so that you can have a complete circuit. So I'm going to label this as I've got a wire going to ground, and I have a resistor also, because with these LEDs, you cannot have them take power all alone. Otherwise, they will burst. It's too much power. So I have this LED connected to a resistor in order to regulate some of the power going into the LED. So this resistor here is going to be about, let's just say 300 ohms. So a 300 ohm resistor will regulate the power that comes from the microcontroller into the LED so that the LED does not blow up. Okay. Now here's the thing. In order to control what the LED is doing, I'm going to have to connect this part of the circuit to a pulse width modulated pin on the Teensy. Now what essentially this does is that when I connect it to the pin, so let me just pick a random spot here. When I connect it to the pin here, the programming code which I will upload to the Teensy basically gives instructions from the pin which I designated as. Okay. I'll stop this section here so that I can just build the circuit and show you, and it will make a bit more sense. Okay, so here I have my circuit board with the Teensy microcontroller here, and this is what it looks like. You can buy them off of eBay, Amazon, and certain other websites, either with pins included or without pins. Now, I don't suggest you get them without pins because it means that you'll have to solder them on yourself, and you know, I don't expect many of you to actually have a soldering kit. So mine comes with pins already soldered. So this is the schematic for the Teensy. Okay, and as you can see, the schematic gives you an overview of every single pin on the Teensy. Now, most of these colored symbols we don't really care about. We really care about the voltage in at the top right, the ground, and the selection of pins that we see here. That's really all we care about for, you know, the next couple of tutorials. So what I'm going to do first of all is that I'm going to define ground and have that be connected to the circuit board, and I'm going to define voltage in and have that also be connected to the circuit board. Now for this first part, we aren't actually going to use voltage in. Okay, we are simply just going to control the LED just from the power of the microcontroller itself, and that means we have to connect it to one of these input pins here. It won't take parasitic power itself. In fact, this voltage in can be considered as parasitic power. Anything connected to it draws power continuously, even without the microcontroller giving it instructions. However, anything connected to any one of these pins only draws power when the microcontroller says so. And the microcontroller says so by the way you code on the IDE, which I will get to once I've built the circuit. So let's build a simple complete circuit with an LED and a resistor. So the first thing I'm going to do is that I'm going to plug in my voltage in. So it says here that the voltage in is this top right pin here. So I'm going to plug in my pin there, and I'm going to wind this back and just put voltage in all along this strip down here. I also needed to find what ground is. Now on the schematic it says that ground is the top left pin here. So I'm going to use this solderless wire and I'm going to plug that solderless wire in there and just have ground on the blue strip here. And this is how it should look. Next thing, I'm going to plug in my LED. Now, this is typically how an LED looks. It has a long side and a short side. The long side always connects to ground. Sorry, the short side always connects to ground and the long side always connects to whatever pin or voltage source you want. So I'm going to do it as such, like this. So the short side of the LED is connected to ground. I have not yet connected it to the microcontroller because I first of all need to plug in a resistor. So I don't know what value this resistor is, so I'm going to use my multimeter to tell me. So I'm going to set my multimeter to measure resistance. Just clip on the wires as so. And my multimeter tells me that I have a 220 ohm resistor. That's cool. That should be enough to regulate the current flowing through the LED. So we'll use that. So I'm going to plug my resistor in series with the LED. Doesn't matter which way around. Push those pins right in there. So this is how it looks so far. The last thing I'm going to do is that I'm going to decide what pin I'm going to plug the whole LED resistor combination to. And I've decided that I'm going to plug it onto pin number 23. If you can see that. I'm going to plug it on into pin number 23 using one of these wires here. So I'll just plug that right there. And pin number 23 is the fourth one down. So this is pin number 23 here. Just like that. So that's our first complete circuit. Now the next thing to do is to put some code on the Teensy microcontroller, which will tell it how to control this light bulb. So in order to begin to put code on our microcontroller, we need an IDE. We need a code editor, so to speak. And the most common one to use is Arduino IDE. You can catch this on arduino.cc. You can catch this on Arduino CC via the software downloads section right here, and download Arduino 1.8.9 whether you're on Linux or you're on Windows. So I'll just go through this very quickly. The first thing I'm going to do is that I'm just going to describe what my code is expected to be doing. This code is a simple set of instructions to blink one or more LEDs using time delay. Okay. The first thing I'm going to do is that this is sort of my initialization step. Okay. I'm going to initialize what the name of my LED is and what pin number it's on. So I'm going to do that via int. So int is a keyword that stands for integer, because the pin numbers are all integers, 1, 2, 3, 4, 5, 6, and so forth. I'm going to call it green LED. When I code, I like to use meaningful name, a meaningful naming protocol, and I'm going to attach that as I stated pin 23. And then the syntax for the Arduino IDE is based upon C. So you must put colons, semicolons after every line. So I've initialized basically my green LED, and I basically said that it's connected to pin 23. Or rather, what I've done is that I've actually just taken a number and I've called it something. So this number 23, I've made sure that the ID knows that it's an integer, and I've called it green LED. I actually initialize what it is in this section here, which is void setup. Now this is where I define a pin mode. Now notice how it turned orange there. That means that it's a keyword. And I'm basically letting the Arduino IDE know, oh, this particular pin number, what kind of pin is it? So first I have to initialize the pin and then tell Arduino IDE what exactly it is. So pin mode green LED, and it's going to be an output, okay? It's going to be given instructions. It's not an input. I'm not sending information from the pin into the microcontroller. No, the microcontroller already has code and it's going to give instructions to said pin. That pin is pin 23, and the pin's name is green LED because that's what the green LED is connected to. Okay, so this is a very, very simple step. The next step is exactly what I'm going to be doing to that pin. What instructions am I sending to that pin? Okay. The LED is a digital circuit component, so I must use the keyword digital write. Okay. This is basically what instructions am I sending. Digital write is the keyword for send this particular instruction. Okay. So digital write green LED and high. High is a keyword for on. Okay, so I'm gonna just comment that. High is a keyword for on. So this basically says turn on the LED. Now the key theme of this code is using time delays. So I'm going to delay for about 1000 milliseconds. Okay, the number here is in milliseconds. So this delay is a keyword in Arduino IDE for wait. So the line here says wait for 1000 milliseconds or 1 second. 1000 milliseconds is 1 second. Then I'm going to send another instruction to the LED to switch off, and the keyword for this is low. Low is a the keyword for this is low. So low is a keyword for off. And you can think of high and low in terms of how much voltage the microcontroller is sending to that particular pin. High voltage, give it all the voltage it needs to stay on. Low voltage, take away all the voltage it needs to turn off. And I'm going to tell it to wait for another second. Okay, and let me just comment here. This is where the pin is labeled as an output pin and initialized. Now this line here is just me calling a number, giving a number a meaningful name. So 23 is a constant, so I'm just naming a constant. Naming a constant a meaningful name to use in the rest of the code. Now one last thing which you may or may not need to do, depends on what kind of microcontroller you use. Since I'm using a Teensy, I had to install um, a new set of libraries that that Arduino could use to read the Teensy. You may not need to do this if you use any of these Arduino boards. I use a Teensy, so you know this is what I have to do. Using a Teensy 3.5. USB type is serial because you're going to connect the microcontroller to your computer via a USB. And port number is, this step is usually automatic because once you plug in your microcontroller into your computer, it will automatically register to a port. Okay. So what I'm going to do now is that I'm going to plug the Teensy into my computer using a USB 2.0 cable, as so. And the other end of this is connected to one of the USB ports on my computer. Okay. Now, my light is already flashing, but I'm not going to show it to you because I want to be able to control it via the actual program on the Arduino IDE. So once you're done plugging your Teensy in, it should show up here, and as I stated, it's typically automatic. So the computer recognizes that I have a Teensy connected to my USB port, which is called COM3. Now what I'm going to do first of all is verify that this code makes sense, and I use this tick icon here, and I'm going to call that blink delay. So I have an error, and I have this error because I forgot my semicolons here. That's fine. So just put the semicolons there. Try again. Okay. Sometimes it takes a while. So that's accepted. Very good. So now I'm going to use this icon here, this arrow, to upload onto my actual board, microcontroller. And that code has been transferred onto my Teensy. And once we go back to the Teensy, we should see it flash every second. So as you can see, my LED is flashing every second. Now the thing is, I can control how fast it flashes by changing the code on the Arduino IDE. So rather than it flashing every 1 second, I can tell it to flash every half second just by changing the numbers. So going back to the code, changing 1000 to something like 500, which is half a second, uploading it to the Teensy, and it should begin to flash faster momentarily. See, it flashes faster. Let's halve that again. So a quarter of a second, so 250 milliseconds. Just enter that in, upload, and it should start blinking even faster momentarily. Okay, let's go even further. 1/8. So 125 milliseconds, 1/8 of a second. Upload, and it should start blinking even faster. Now let's say I want it to blink every 30 milliseconds. Let's say every 30 milliseconds. I want it to go crazy. Upload, and it should blink even faster. That is epilepsy on a circuit board, because these LEDs are bright, and it's especially why you need these resistors to control or regulate the power. Otherwise, too much power gets into the LED, they get too bright and they blow. Okay. Now, in this tutorial, what has been basically demonstrated is how to build a simple circuit and flash an LED using some simple coding. However, this is it's very tiresome having to go back to the code and change it every single time. Okay, so the way we can improve this circuit board or this blinking LED example is to put an input. So once we've uploaded code onto it, we should be able to change something manually here, right here on our circuit board that can control the blinking. And this is what we'll touch upon in the next video.